trying to bring innovation and novelty in certain areas of the space domain where some challenges still have to be overcome. One of the main challenges is the cost that you have to bring assets to space. Imagine that you're running a race and your first goal is winning the race. You cut corners, so you have to be the first delivering a payload into space. You don't care about how much mass you're actually putting on your launcher. When you start caring about that is when cost comes into play, and basically when you will have to start providing a commercial solution to your customers. iImpulse is one of the small launchers, micro launchers company with very interesting plans to grow way beyond the small launcher sectors, and they saw something which all the other companies will have to face, which is beyond being first winning the race. You will have at a certain point to be commercially sustainable.
Lattice structures offer excellent performance to mass ratios thanks to the fact that they really strategically place the material exactly where it's needed, and after more than 10 years of research, we are beyond that point. Our lattice structures are made for a one-shot manufacturing process. We lay up our structures on a single mandrel, and then the entire part gets cured at once within a single autoclave cycle. So we're not making multiple parts that we then assemble together. We have a single continuous structure, be it a payload adapter, central satellite tube, or interstage. So what we get out of our manufacturing process is a lighter, stronger, more accurate structure, which is also simpler and cheaper and faster to manufacture.
Scalability comes into play exactly when we join forces with Airborne, because right now our technology is produced manually, and Airborne's technology can allow us to do that in a machined way.
Airborne has been active in the space business for more than 15 years. Our company makes composite parts for aircraft, satellites, and launchers. The traditional way of making high-end composites is we cut the material, we lay it down onto a mandrel, a mold, and then it is cured in the autoclave, machined, and ready for integration at the customer site. But this is also a very labor-intensive process. Putting the process of the material deposition on a robot makes it 10 times faster.
The robot behind me is an automated tape laying machine, and it lays down white tape, which is 150 millimeter wide, in order to make flat laminates. Out of these flat laminates, we made our solar panels, which we sent into space. We are developing this together with SomXL. At SomXL, there's a robot available that can lay down narrow tapes, which is more suitable for 3D structures, such as a conical shaped payload adapter or a cylindrical part of a launcher structure.
Our collaboration with ATG is a special one. ATG developed this grid-stiffened design concept. Airborne brings the knowledge how to make them, how to manufacture them, but also how to industrialize the process.
Together with Airborne's technology, to improve our commercialization and scalability of our solutions for our current and future customers.